Okay, I'm about to reveal the answer. If you run this through Fitz's law, the first example, the small circle, short distance, is 1.9 bits for the index of difficulty. And if you crank through the other numbers, you get 1.2 bits for the index of difficulty for the largest circle. And so because we have a larger index of difficulty for the small circle that's closer, that is the more challenging target. So it's easier to hit the larger circle that's further away in this instance with these measurements. So what does this imply? Well, large targets and small distances between targets are advantageous. Screen elements should occupy as much of the available screen space as possible to avoid large mouse movements. So if we compare the interfaces for Word 2003 and Word 2007, we can see that there's a bit of a difference in the design, right? We have the icons all similar size in 2003, but in 2007, we have the ribbon with some design optimizations. You have bigger targets for common actions, for example, copy paste. And you can move some buttons to the edge of the screen. What does this let you do with these buttons at the edge of the screen? Well, it gives you an infinite target, effectively. Mouse cursors stop at the edge of a screen, so the corners can be considered an infinite width. And if you're going straight up, you have a bit of a width, but in one direction, you've got an infinite target. So the user needs a lot less precision because they can simply fling their mouse in the direction of a corner. So in macOS 10, I use hot corners to be able to reveal my desktop or show all my windows. And that works because you can just fling the mouse into the corner and then it triggers it. And it takes no time at all because you have an infinite target. So menus at the top, bottom, and side are infinite in one dimension. And this means that they're easier to hit and thus faster to be able to acquire those targets. Another implication might be a pie menu. Large menus like pie menus are easier to hit than other types of menus because all options are equidistant. If you have a linear drop-down menu, some of the closer items will be faster to hit, and the further ones will be harder to hit. But with a pie menu, all of them are there, so you don't have a bias. You don't have to worry about the order of the different options. And you also have infinite width in one direction. You just have to make sure you're within that angle, so it can be quite fast to acquire a target using a pie menu. Another use of Fitz's law is to specifically compare interaction devices. Given the same task, you can measure the index of difficulty across different devices. For example, to find out that a mouse is faster than a joystick, which is faster than arrow keys. And this has been used extensively in HCI to be able to compare what interaction techniques are faster or easier to use. So now it's your turn. I want you to follow the instructions and learn to go to this Fitz's law simulation online and record 2 or more data sets. And I want you to try and compare 2 things. For example, either compare the mouse versus the trackpad. So do the Fitz's law test several times with the mouse and then do it with the trackpad. Or try your left hand versus your right hand and see if you're ambidextrous or if one of your hands is faster at acquiring these targets with the mouse than another one. So go ahead, follow the instructions and learn to submit, and I'll wait.